All right, welcome to Chapter 8, 8.1, Basic Integration Rules. This first video hopefully doesn't take too long. These are just reviewing of integration. So I'm going to actually have you do example 1 all on your own, see what you remember, and then when you complete all 3 of these, A, B, and C, come back and check, and we'll go through each one of them quickly. All right, so A, hopefully you recognized, is a quick substitution. We're going to use those inverse trig identities there. So we let A equal 2, U is x, so du is dx, and we rewrite that, and we get our final answer of 25 over 2, arctan of x over 2. Don't forget, plus C. Number 2 is a nice U substitution, no fanciness here, all right? So hopefully you let U be x squared plus 4, so du is 2x, and it works out nicely. So 25 over 2, you can pull that 25 out, times the integral of 1 over u, and then that's just bringing up ln of the absolute value. Notice the final answer after I substitute back in. I don't need the absolute value anymore because x squared plus 4 will always be positive. And of course, don't forget, plus C. This last one might have tripped you up just a little bit. We can't break up this integral. If we try to do a U substitution, it's not going to work out very nicely. All right, so what we can do is some long division. All right, so we can divide these two. So x squared divided by x squared plus 4. What times x squared plus 4 gives us that x squared? It's just 1. And remember, we're going to subtract that, so we get our remainder here. And we can go ahead and rewrite that. So basically, we can rewrite x squared over x squared plus 4 as 1 minus 4 over x squared plus 4. So we're integrating this guy, splitting it up, moving that 4 out front. We can now do a U substitution dealing with arctangent. All right, so this guy should be easy. The integral of 1 dx, we get 25x, and then 25 times 4 times the integral of 1 over a squared plus u squared du, and we've got our 100 over a, arctangent of u over a. Don't forget your plus c, and we can make that substitution on back. So I know I'm going through this quickly. That's kind of the point. It's all just review. But one thing you do want to note is here's kind of our little cheat sheet here. Those basic those basic integration rules. All right. So reminding you all of those guys, and then also getting into our trig functions on the right here, well, towards the bottom of the left as well. So just reacquaint yourself with those, and let's try 2 more examples on the back. Okay, so this second example here deals with a little tricks, a few tricks, I guess, especially this first one, A. So if we were looking at this example here, we would try to use substitution, right? 1 plus e to the x, but that's not lending us to use a U substitution because we'll be left with an e to the x after we take the derivative. So one thing we can do is we can add e to the x and then subtract e to the x to that numerator. So I'm not changing the value here, but what it's doing is it's allowing me to then break up this fraction. So we can say it's the integral of 1 plus e to the x over 1 plus e to the x minus this portion, e to the x over 1 plus e to the x. So this is going to allow us now to make a U substitution because these guys cancel, leaving us with the integral of 1 dx, and now we can use our U substitution in the second one. If we let u be 1 plus e to the x, then du is that e to the x dx. So that takes care of this piece. We can integrate this guy very easily. We get x minus the integral of 1 over u du, and now we can integrate it. So x minus ln times the absolute value of u. Don't forget your plus c. All right, and then we can make our substitution back, and we get our final answer there. Again, I can drop the absolute value because 1 plus e to the x will always be positive. So in order to make that U substitution, the trick is adding and subtracting e to the x. Otherwise, that U substitution just won't work. All right, I'm going to let you guys take it from here. So go ahead, this last example, integrate x times a cotangent of 2x squared. After you go through it, come back and check how you did. Hopefully you recognize this is a straightforward, relatively straightforward u substitution, where u is 2x squared, so du is 4x dx. We can bring that 1/4 out front, and we're just integrating cotangent of u. So this is just a reminder of, oh, what is the integral of cotangent of u? All right, so remember it's ln of the absolute value of the sine of u. Don't forget your plus c, and now we can substitute on back. So reacquaint yourself with those trig identities, all right? And one thing I want to note that if the trig identities might need to be used if particular trig function is not on the list of those basic integration rules. So that takes us to the very bottom, all right, of those integration rules. We can expand the numerator, we can separate the numerator, which is what we did in that example A up above, to allow us to use a u substitution, completing the square, divide and proper integrals, that's what we did on the front side, add, subtract terms in the numerator, that's essentially what we did in example A, use trig identities, all right, multiply and divide Pythagorean conjugates there. All right, so those are the integration rules that we're looking at. We will see each other in class.